Alrighty, so today we're going to be looking at exact values of sine, cosine, and tangent. So what does that actually mean? Well, I guess what the purpose of this is going to be is to make sure that we have a handful of values that we can actually evaluate without a calculator. So in particular, we're going to be looking at two different triangles and then also what's called the unit circle, depending on what we're actually looking for. So let me introduce you to the first of the triangles. Now this triangle probably will look pretty familiar. It has a right angle here, and it's an isosceles triangle, which means these two sides are actually the same. And what lengths are these two sides that are the same? Well, they're both one. One what? 1 unit. And using a big Pythagoras' theorem, 1 squared plus 1 squared, take the square root, is the square root of 2 is the other side. Now this triangle comes with two angles, and those angles, because it's an isosceles triangle, are the same. Now if you remember, they should add up to 180 degrees. And we've already got 90, so we're left with 90. And if we divide that by 2, we're left with 45. So we have 45 degrees here and here. Now 45 degrees can also be written as radians, and that as a radian is pi on 4. So we can sometimes call this the pi on 4 triangle, or sometimes the 45 triangle, or you'll often hear it called the 1 square root triangle. So let's think about the other triangle that is going to be really important to all of this. Now this triangle is slightly different. This triangle here has a side length of 2 and a side length of 1. In fact, I've drawn the 2 in the wrong spot. The 2 should actually go here. 2 squared is 4. 4 minus 1 squared is 3. So this side also by Pythagoras' theorem is going to be 3. Now we've got two angles in here. One of them is 30 degrees and the other is 60 degrees. The smaller angle is 30 and the bigger angle is 60. So these are two of our basic triangles. Now, just to be mindful, 30 degrees can be written as pi on 6 radians or pi on 3 radians for 60 degrees. So these are our two triangles, the 1, 2 square root 3 triangle and the 1, 1 square root 2 triangle. These two are really important. But the other thing we've got to get our heads around as well is the unit circle. Now the unit circle is a pretty basic concept. Oh, let me try my best to draw a circle here. Is a circle in which the radius is 1. So this is 1, and this is 1, and this is 1, and this is 1. So it's centered at the origin, and its radius is 1. And this is x, and this is y. Okay? Now, there are a few interesting points on this circle. They're not that interesting, but they're going to be very useful. This point here is 1, 0. This point up here is 0, 1. This point here is -1, 0. And this point down here is 0, -1. And the point of all of this stuff is to say that when we talk about a point, a general point on this circle with some angle theta, this point represents the x-coordinate is the cosine of theta, the angle we've been given, and the sine value, the y-coordinate, is the sine value of theta. And so in general, when we start to actually think about trigonometric functions, we stop really thinking about these triangles and start thinking about the unit circle. But with this, we can get all of our basic exact values. And the only things we need to remember is SOHCAHTOA and then the unit circle for otherwise. And on here, we have some important angles to remember. We have the 0 degrees, 0 radians. We have the 90 degrees, pi on 2 radians. We have the 180 degrees, pi radians. And then we have the 270 degrees and the 3 pi on 2 radians. And also, because of this, we can also do the 360 degrees, which is the 2 pi radians. Obviously, 360 and 0 are kind of the same, but they're also kind of different. So here is our total picture, and with this we can work out every exact value of sine, cos, and tan that we need. So if I'm asked what is the cosine of 45 degrees, well, I know cosine is adjacent over hypotenuse based on trigonometry. If this is my angle, then my adjacent is going to be the square 1, and my hypotenuse is going to be the square root of 2, and we get 1 over the square root of 2. Now that's sometimes how it's written. However, you'll often see it written what we call with the surd move to the top, essentially. So this is like an optional step, and that's to multiply both top and bottom by the square root of 2, and which gives us square root of 2, because 1 times the square root of 2 is just 1, and square root of 2 times square root of 2, well, that's just 2. So either answer would be perfectly acceptable, square root of 2 on 2, or 1 over square root of 2. Let's try a different one. What if I asked you for the sine of pi on 3? Well, the sine of pi on 3 is actually the opposite over the hypotenuse. So let's find pi on 3. Well, pi on 3 is this angle here. The opposite would be square root of 3. The hypotenuse would be 2. And we get the square root of 3 on 2. And you'll notice that this is perfectly fine. Why? Because we're not writing the square root of 3 on the denominator. So that's perfectly fine. Now we're going to do 2 more. The next one I'm going to look at is the cos of pi on 2. So pi on 2, you'll notice, is not in either of these 2 triangles. In fact, where can we find it? We can only find it in one spot, and it's actually here, this angle here. And because we're interested in cosine, that's the x-coordinate. And the x-coordinate of that point here is 0. Now, the problem is going to be tan. Tan is annoying. So let's do the tan of 90. Oh, let's do the tan of 0 degrees. So the tan of 0, well, where does tan live? Well, tan actually lives, and this is going to be an important one, tan, because you'll notice on the unit circle we actually haven't written tan anyway. We've only put cos and sine. Cos being the x-coordinate, sine being the y-coordinate. Well, tan of theta can be written as sine of theta over cosine of theta, meaning you take the y-coordinate and you divide it by the x-coordinate. Alrighty, so if we've got the tan of 0 degrees, well, we can just work out the sine of 0 and then divide that by the cosine of 0. So the sine of 0 is going to be 0. The cosine of 0 is going to be 1. So it's going to be 0 over 1, which is 0. So here is how we can actually do these exact values. Now, over time, we're going to learn some strategies to make this a little bit faster. However, at this point, we just need to be able to calculate them. Alrighty, I'll see you in the next one. Goodbye.